it over to James.
Hey, thank you very much. All right, we can go to the next slide, please. Okay, so just I want to talk a little bit about the changing analytic environment today. My name is James Curtis. I'm a senior analyst at 451. For those that may not know about 451, let me just give you just a quick brief background. We're a research advisory company. We were founded in about 2000, so coming up on 20 years, I guess. A little over 300 employees. A little less than half of those are analysts. A lot of those analysts publish content, like myself. But what I want to draw your attention to, because I'll be mentioning it a little bit in my presentation a little bit later on, is the fact that we have a pretty large sort of IT professional business group that we reach out to, kind of 50,000 plus and growing, which we either talk to them and query them and reach out to them on a regular basis to see what they're experiencing in their business. And I'll share with some of that with you again today. So we're headquartered in New York City, but we have offices on both coasts and in Asia, as well as Europe, and as well as Central South America. All right, next slide, please. So just a little bit about what we cover at 451. I just kind of want to show this slide, but we cover a lot of technologies within sort of the IT space. From data centers to networking and storage. We'll be talking today about kind of data platforms and analytics, which is kind of about the center of this chart right here. But we also cover into IoT and mobile as well as enterprise mobility as well. So that's just kind of the scope of what we do at 451. So next slide, please. Okay, so one of the things I'll talk about today is I'll talk a little about the group I'm in, which is called Data Platforms Analytics, and kind of how we define that. We'll talk about some market metrics related to that. Also share with you some trends that I've been seeing that we've been tracking. And then I'll also talk about how the concept of the data warehouse, what we know it today, and how that has been sort of evolving and changing over the past several years. And then we'll also get into a little analytics. That space has also been progressing and evolving over time as well. And then hopefully I'll leave you with some hopefully brief and concise takeaways that could be helpful to you as you go back to your organizations and where you might work for your day job. So, all right, next slide, please. Okay, so 451, myself as well as a number of other colleagues, we're part of a group called the Data Platforms Analytics. And I'm just essentially kind of showing you this slide here just to kind of to show you how we sort of segment and sort of divide out the market. And then we cover these and then we write research and do some other things on them. But essentially what we're going to be talking about today, just give you some context, is really technologies kind of store, process, and analyze data. This includes a lot of databases, a lot of platforms, a lot of open source software as well. But it's the idea of collecting, analyzing, and then taking that data and then sort of finding value in that, or making some decisions based on that data that you find. We'll be covering operational analytical databases, Hadoop, data grid and cache, event streaming, also some of the data management systems, as well as systems that not only prepare data, but also allow you to sort of do more advanced analytics on them as well. So just give you some context of that. All right, next slide, please. Okay, so now that you have sort of see the coverage area, what are some trends that we're seeing? Well, every year, towards the end of the year, and we'll do it again this year, 451, we publish sort of a trends document. Some of the trends that either we seeing or ones that we expect to see and sort of their impact on the market. I've pulled at least 3 of them here. It's not an exhaustive list, but at least 3 that I think are relevant for today's conversation. One of the trends we see is stream processing, and the idea that organizations will have to grapple with the idea that will come to them on a very immediate basis. And some of our recommendations are that can an organization's infrastructure and environment handle sort of streaming data? And the idea of understanding the idea for use cases associated with that. So as it turns out, not all organizations actually need to or want to have a streaming use case, but organizations are finding ways in which that becomes very relevant to them, depending on the sector and business that they're in. And the other one, another trend we see is the blurring of the line between sort of analytical and operational analytical databases. So Traditionally, you know, it's been, I'm going to do my transaction processing on one system, and then I'm going to do my analytics on another system, and never the two shall meet, because in some ways the analytics could potentially, because they are often compute heavy, could potentially disrupt what's going on the transactional side. You don't necessarily want to impact that for low latency. So those have often been historically seen as two separate systems, but there's actually a number of use cases where you can bring those two together and it actually makes a lot of sense. And so the idea is that to not necessarily think in this bifurcated world, but to think in ways in which you might be able to blend and meld those two. But also thinking about the skills an organization may have of traditionally these have been sort of two groups of people, but it's possible that that can actually be a single group of people or someone with sort of dual skills or thinking that way. And then the third trend we'll talk about is really around machine learning and deep learning and how this is sort of being adopted and taking off in the market. The idea that you know, these types of analytics, these more advanced analytics can help businesses are something that businesses are actually kind of clamoring for. But there's often this idea of, you know, how do I balance sort of the complexity of that with sort of the user friendliness of making it sort of broadly applicable. So we'll talk more about some of those things, but these are just generally some trends that we're sort of seeing playing out. All right, next slide, please. Okay, so as we sort of, so as I sort of painted that picture with sort of those 8 segments a few slides ago, we really anticipate this market a growing market, and sort of we don't. I want you to sort of look at the slide, but I don't want to suggest that every segment is sort of equally in growth. That some will have more growth than others, but collectively, you know, we're looking at like an $80+ billion market. It's going to balloon up to, you know, almost 140 billion. And that really shows that data will continue to rise, as we'll talk about it. But the idea of analytics and sort of finding value in that will also be a critical component of that. And then technology sort of weaves through that as it enables us to sort of carry some of that out. But you can see that's a healthy 11.5% CAGR over these 6-year periods. So again, a growing and healthy market. All right, next slide, please. Okay, so just we'll kind of take a little stopgap here for a minute. Is we'll talk about some of these trends. I kind of threw this quote in here. Is that you know, for organizations that are not necessarily aware of the trends or maybe potentially ignoring them, that you might do so at your own peril. That these things are happening around us. And what often happens is that no business organization will essentially operate in a bubble, that they have partners and customers and different things. And all of these areas are also expanding well. So by virtue of sort of that larger ecosystems of which organizations play, that they are in some ways forced, but they should want to sort of embrace some of these trends and these technologies moving forward. All right, next slide, please. Okay. So let's just sort of level set for a minute, is that we have normally thought of sort of the data warehouse as sort of this monolithic system. You know, the idea that I'm going to put some structured data, maybe from an ERP system or some kind of system. I'm going to offload it and throw it into this sort of this singular system that I have. And that's where I'm going to do all my analytics. And as I do that, I'm going to have a set of users that sort of want access to those analytics, of which I will then make assessments or decisions, business decisions based on that data. But historically, there's been somewhat of a gatekeeper with IT. Now, that's not to sort of beat on the IT drum, but there was good reason actually for that. And what some of that is for standards and to keep some of this data carefully secure. But that gate also meant that there had to be a series of levels in which, you know, someone might reach out to IT, then they would get access, and then there's sort of a roll-up of that data maybe with a BI tool. And then eventually it might make it to sort of a decision maker to sort of make decisions on that. So you can see that the latency and the idea of say, a timely decision could particularly be impacted, especially if it was significant. So how might we sort of broaden our view of that? So we can go to the next slide, please. So as we sort of go through that, if you just, this might be a build, yeah, go ahead and put that out. Okay, great. So as we sort of expand our view of, say, of what has normally been the data warehouse, we are seeing some changes, and I'll just mention a few changes here that are having a pretty significant impact of not only how organizations view the data warehouse, but how it's actually being used and implemented within organizational environments. And I won't spend a lot of time on data, but IoT and some of these things, sensors and ways in which we can sort of collect and manage data is propagating at a pretty phenomenal pace. And so we don't actually anticipate that will slow down. In fact, it will grow in perhaps, multiples of orders of magnitude, right? And it's sort of, the idea now becomes sifting through some of the relevance of that. But there's also organizational expectations that are driving this change. As I mentioned before, sort of this gate between IT and decision makers and other experts, that is sort of playing out. But now organizations are realizing that there are actually a lot of smart people in organizations, and if they can get access to that data, they can cut down on some of this latency, but also they can share the insight across organizations, okay? And so now the idea of self-service, the idea of others sort of accessing, gaining access to data, and then performing some kind of action on that is greatly appealing to organizations, and they're making accommodations to do that. So another one is storage, and maybe I should put storage and memory here, is the idea that the data may not necessarily reside in a single place. If you've not heard already, the idea of data gravity, the idea that where data might be produced and then where it lands is often where it sometimes stays. And just like water may seek, the level ground, data tends to sort of reside and gravitate to where it sort of makes sense to stay. And then moving that data actually causes a great deal of challenges, as well as a penalty and a latency time to necessarily do that. But beyond that, we're seeing not only different types of storage and memory available, but we're also seeing, cloud storage and object storage, and then different types of storage in the cloud. Is it hot? Is it cold? And then being able to do that. SSDs and the price of memory and different things are sort of coming down. And so we see a lot of sort of mixed systems going on. Another one is open source software. Is that not only, I rarely bump into organizations that say, we don't use any open source software. A lot of it is the mandate to actually use open source software and then integrate it into an environment. There are controls and there are things around to sort of manage that, because open source by itself can sometimes be raw, but actually fills significant gaps in the market, particularly around processing engine. And so we're all familiar with Hadoop and Spark and others, but one of my colleagues recently wrote a report, there's probably 70 plus Apache projects out there that have very specific purposes. Some use more than others. And that number might be, significantly higher now. But you get the sense that there are a lot of these projects and they fulfill a need in the market to give people, fill gaps in their environments. And then the third is compute options. Not only are we seeing CPUs and multi-core and on the hardware side, but we're also seeing the nuance or the introduction of sort of hardware accelerators, things like GPUs and FPGAs and other things that are sort of making their way into be more mainstream processing vehicles, and then people are sort of offloading and doing analytics on those systems. So these are just sort of a encapsulation. It's not meant to be an exhaustive list, but some of the things going on. So next slide, please. All right, so this takes back to, how do we expand our field of vision within the data warehouse? Again, how do we think beyond where we are? So if we can go to the next slide, please. So in the center blue here, we see that we greatly have expanded processing choices, okay? Not only do you have sort of your data warehouse, but you also have Hadoop based systems. You have Spark, you have other maybe open source things. You now have machine learning algorithms and libraries and things that might be part of that. And now the idea becomes, as I get data, which sort of processing engine makes sense to sort of do that? And some can be better. Now we'll assume that maybe there's an ETL process stuck in there somewhere, but it makes sense that as you get data, there might be some data that might be more useful, and you might want to process it a certain way. You might want to do other data. So now it becomes, in some ways, an integration game or integration play of which you sort of put these things together. So if we go to the next slide, please. So now that we've sort of expanded that, we've certainly expanded our ways and means in which we can get data. Okay, not only is it sort of structured data, but now we're getting logs and we're getting things off mobile phones, and bots can produce data and different things, as well as IoT devices. And now all this data is coming. I don't expect that every organization will have every single piece of data that's listed here, but this gives you representation that you'll most likely have more than one. You might most likely have a collection of different type of data. And the idea is sort of landing that in your system, and then how you might want to operate and process on that data. So we'll go to the next slide, please. So as data grows and as our ability to sort of process and sort of operate on that data, we also have the idea that the individuals or the people that want to sort of carry out actions on the data also increases. So we have business users. We also, IT is still involved, but now we have different flavors of data scientists and others that are perhaps using that data in different ways than what we had before. In many ways, this is driven by sort of self-service. This is driven by the ability of better and broad tools that do extensive visualization and other capabilities that then allow us to sort of grab and capture that data and then sort of present it in different ways we didn't necessarily have before. Okay, so next slide, please. Okay, so this slide is going to start out in the next three is that, as we particularly talk about analytics, how have we sort of seen this particular space sort of expand and evolve over time? So this is the first slide, but on the left side, we'll see that, we first started out with sort of an IT-driven world, again, where, we primarily were seeing, what historically happened, or what, and then maybe why did that happen? Okay, and we did some analysis on that. Okay, but next slide, please. But then as we realized, as I mentioned, that we now had a number of individuals that wanted more access to that data, and we sort of more of a user-driven, but we also became more sophisticated in sort of our visualization tools, both the number of them and the capability of those tools, that we went to more advanced statistical modeling, right? And we were able to say, what do we anticipate will happen? Where do we think this market is going? Where do we think, we should put our next retail store, or, what product or thing should we do? And we were becoming a little more advanced in that. We're also saw the emergence of sort of streaming data as it was sort of coming in to the system, and that helped us to say, what is sort of happening now? How are we, dealing with a situation now? And if we go to the next slide, please, we're really headed to the idea that as we use sort of advanced statistical modeling and machine learning, we're essentially going into a more advanced state. Okay, we're looking at sort of more intelligent driven, more sort of machine learning driven applications, where not only are we sort of looking at what did happen and what is happening now, but we're going to get to the state or the point to where we can look at how can we influence what's happening right now, right? And the classic example is as we look at maybe a retail example, as someone enters maybe a store or some kind of a business, and they might have a particular mindset of what they want to do. How might we influence that, right? And how might we use data to sort of influence that decision? So we're getting to the point, this could be the same for online as well, right? When you visit, say, an online store, how might your action be diverted to an influencer using data to guide you in a particular direction? So again, these are things that we're seeing sort of analytics. So maybe to sort of wrap up, we can just get the next slide, please. There's a couple of key takeaways, and I'll turn the rest of the time over to Mike, and then we'll be able to take some of your questions. Is that data warehouses are certainly moving away from sort of the singular monolithic environment to really sort of a integrated environment, right, where it's architected and it functions in the way in which that's often dependent on data and processing and those users. Data will continue to be a need. Or sort of, it will continue to not only be a need, but also will continue to grow at phenomenal rates. And it's not so much about the system as it is I have data, what am I going to do with that data? The technology, some way, is a tool to make value out of that data. And then the third point here is really about data access. The idea is that the more we can sort of broaden the access of that data, also have controls over that data and different things, but the more we can sort of broaden that data, we should be able to find greater ways to sort of leverage that and to find insight on it. So again, thank you very much. With that, I will wrap things up and turn the rest of the time over to Mike. Thank you very much.
Excellent. Thanks, James, for that fantastic introduction and overview as to what's really forcing some change within the data architectures and analytic landscape. So what we'll do now is transition a little bit into a more of a technical view that is influencing and ultimately directing new investments, new architecture investments for addressing new analytic requirements. So at the end of the day, the requirements of the data warehouse ultimately is changing. As James has pointed out, there's a number of drivers for those. Here at MemSQL, we see a lot of organizations struggling with just the variety and velocity of the data through web applications, different telemetry on devices, et cetera. But most importantly, I think there's becoming more of a culture of performing analytics continuously. So more operationally oriented analytics where business users can adapt and make decisions and act on data throughout the day. And so a lot of what we'll be talking about today is how to address some of those more real-time requirements of your data warehouse, taking advantage of some of the existing architectures and supplementing those with new modern architectures. So some of the specific things that we see that's driving organizations to look at new technologies surrounding their existing architectures for data warehousing. It has a lot to do with performance. Of course, everyone wants to be able to see their results faster. The data sets are getting bigger, so it's becoming more challenging to get those results in a timely fashion. But I think the number one change is intraday analysis. This is the idea that no longer are you waiting for that end of day report. You want to be able to see exactly what's happening with your business in the most accurate view throughout the course of the day. And this is something that ultimately organizations are getting more adept at making decisions and responding to those you know, in a 24/7 or on-demand sort of way. And the data architectures that were designed many years ago never really were conceived to support that sort of scenario or use case. Usability has also been a big challenge for data warehouses. They tend to be brittle and hard to set up, very difficult to scale, can be challenging to tune, and that's ultimately what organizations want, is something that's more self-sustaining, something that's easy to deploy, but also to be able to scale as the usage increases. We see a lot of organizations that are ultimately having to turn away users and their requests because they simply cannot scale their architecture. Optimization is really just another way for saying, I want the most performance for the least amount of money. Ultimately, there are more and more technologies that can address the high performance requirements of data warehousing, but also be able to deliver that in a cost-effective way. And lastly, the ecosystem around the data warehouse is certainly evolving. The ability for the platform to work with other technologies and tools beyond just your ETL or data integration product, but also applications, and now more and more we're seeing machine learning functions and applications driving and putting pressure on your data warehousing investments. And so, of course, what we see is a new approach to addressing a lot of these requirements, and that is through what we call a real-time data warehouse. And so what is a real-time data warehouse? It is comprised of a number of dimensions. These are sort of the salient summary points. The first being that low latency between the data that's being generated and the analysis of that data. So the moment the data is generated in an application, your data warehouse should be able to analyze those results immediately. So that is becoming more and more important, especially for those organizations that have rich data that can be inspected and analyzed immediately. Micro-batching of that data or stream ingestion is becoming much more popular. So batch processes, nightly workloads of data, or weekly loads of data are really becoming a thing of the past. Organizations want changes of their data being reflected in their data warehouse throughout the day, and that's something that has to be architected into the system. And then when you do run your queries, you want those results in sub-second response. That's not just because we're all wanting to be faster and more efficient, it's because that's the expectation of users. Users are becoming much more demanding as to how quickly they want their answers addressed, and your data warehouse shouldn't be the bottleneck for that, especially given some of the new architectures and technologies available. Transaction processing, very important when you're talking about the real-time workloads that are commonly used around IoT applications or just simply applications that have a fair amount of volume of data. The ability to transform and update that data as it lands into the data warehouse in one single process is much more efficient than taking another side route and taking advantage of maybe an ETL batch process, transforming and enriching that data, and then loading it into a data warehouse. Typically, we see that step not only just costly and complex, but also slow. And so transaction processing within the data warehouse becomes much more important when we're talking about faster intraday analytics. Extensibility functions becomes much more important when we look at the emerging class of ML applications. The ability to do custom user-defined or stored procedures or application functions in the data warehouse is becoming much more of a part of the ecosystem that we see these applications becoming more sophisticated and complex. So that extensibility layer becomes extremely important, especially in this era of machine learning. And lastly, the durability for the platform. Usually when we're talking about real-time systems, they are part of the operational frontline of your business. That means it needs to be always on, highly available, and in case of failures, the ability to recover without data loss. And so durability is becoming much more a factor for data warehousing, whereas in the past, if your data warehouse went down for a day, it didn't necessarily impact the business. So we at MemSQL carry ourselves as being a top real-time data warehouse provider, and this is just a simplified view of our product and our architecture. We do provide a stream ingestion capability, so that is the ability to take in data as it is deployed or created from the application. We believe in simplification of the ingestion process, so we have a built-in data pipeline capability that works with a number of other stream ingestion products, message brokers, Spark or Kafka, or even data store such as S3. We also really believe in the exactly one semantics capability. The accuracy of your data is just as important as getting the data quickly. Once the data lands into MemSQL, we have the advantage of a in-memory row store configuration. This is a very fast, transactional, rich environment. It's full SQL, it's full relational, which means your data is structured, which means you have SQL access to all of the data, and it's immediately available for analysis as soon as the data lands into the system. In addition to our row store environment, we have a column store engine, so it's a dual engine environment with row and column store. Column store, very efficient for storing historical data in compressed format, so you can get that history of data, and that history of data can be compressed, so you're taking advantage of compression and lowering your cost of storage, etc. And it's also very fast. So the fact that this is acting as a very traditional data warehouse, we take advantage of query vectorization, we take advantage of query compilation, and we see extreme performance in this part of the engine. The MemSQL environment does work quite well with other complementary technologies, whether it's the ingestion engines of Kafka or Spark, or even historical data sources like Hadoop in terms of HDFS or Amazon S3, and even relational systems like Oracle or MySQL. Many of these inputs these inputs land data into MemSQL very efficiently. We have a very fast, highly parallel processing environment, so we can ingest, in some cases, up to 10 million upserts per second and land that into a structured relational format. In terms of the applications that connect to MemSQL, we can support a number of custom built applications. We do support the MySQL wire protocol, so that means a lot of applications that are already written and connecting to MySQL. We work pretty much seamlessly to those applications. But if you also have business intelligence tools like Tableau or Looker or MicroStrategy, we can connect to those natively as well. And then in terms of deployment, we have a run anywhere philosophy. That means you can run on premises, in the cloud, or as a managed service. So what I'll do now is kind of transition a little bit into some common architectures that we are seeing for real-time data warehousing. A lot of these architectures are addressing some sort of challenge. So in the first case, we see a lot of data lake acceleration needs. So a lot of organizations have invested in Hadoop and the Hadoop ecosystem, and they're doing everything they can to accelerate access to that data. So they have a very large amount of data stored, but then getting access to that data can be problematic, complex, etc. So in this example, we see data all landing in Hadoop. It is a reference store, HDFS, commonly used. And MemSQL can act as the structured layer. So we can actually connect directly to HDFS or a number of other file formats that are part of the Hadoop ecosystem and structure that data within MemSQL. Once structured, of course, now you're able to deliver SQL natively directly to that data and get rich analytics. We can also transform the data. So if you want to do updates, appends, inserts to that data, you can do that within MemSQL very, very efficiently. And lastly, we also see MemSQL serving as an input layer into Hadoop. So we do see bidirectional data updates. And ultimately, this is to accelerate access to key data, so data that may be part of a specific application, or maybe there's a time dimension to the data sets. We see a lot of customers looking at the last 30 days of data, et cetera. So this is one common approach to accelerating your Hadoop investment. Another common technique we see is the use of Spark. Spark is a great technology that allows you to do lots of enrichment in real time, a very fast orchestration sort of engine that allows a number of processing before the data lands into whether it's Hadoop and or MemSQL. In this case, we see Spark sitting right next to where the new data is being originated. This is at some level a Lambda architecture, so you can consider MemSQL to be the hot pipeline of data, taking data immediately and then making it, preparing it for analysis through enrichment with Spark, and then also landing that data into Hadoop. Very common sort of technology or architecture approach. We do have a native MemSQL Spark connector. This means that we can efficiently work with Spark. We see very fast performance. Even though Spark is a distributed system, we have a distributed architecture as well. And so when two distributed systems work together, you want that complexity to be eliminated with simplified connector strategies, and that's something that we deliver with our Spark connector. We also see a lot of organizations taking advantage of Kafka. Kafka delivers a very efficient message broker system, and again, if you have you can, in this case, use Kafka primarily as a message orchestration engine. Once you take advantage of Kafka in front of MemSQL, you can take advantage of our exactly once semantics. This dramatically helps eliminate duplicate data or incorrect data, where MemSQL can essentially clean, transform, enrich that data and then push it into the reference store of Hadoop, and or just serve as a sort of a real-time analytics environment for your near-term data, and then you can push your historical data into Hadoop. A lot of our customers, I would say the majority of our customers, use Kafka with MemSQL simply because of the simplicity of the connectivity and the performance that organizations get from this architecture. All right, more architecture examples. So we have, in this case, you have a legacy data warehouse. So you might be using Netezza or Greenplum or some traditional data warehouse environment, and it's simply not performing due to whether it's more data that's being ingested, or maybe you simply need to get more results out of the system more efficiently because your business wants intraday analytics. So this is a very common approach that we see organizations do where they're pushing data into both systems, both the historical data warehouse as well as into MemSQL. We can take the stream process, we can structure that data and provide analysis immediately, and then push those results into the traditional data warehouse as needed. So the use of change data capture or shipping of logs, depending on what the type of data that you're working with. But the ultimate goal of this architecture is to speed up and accelerate that legacy data warehouse without disrupting or ripping out all of that investment that you've made into that technology. So this is a very efficient way. You have a number of customers that are using us to essentially sit on top of an existing investment and accelerate those reports or provide better concurrency because your number of users in the organization want access to the data, and this allows IT to say yes to those report requests instead of saying, sorry, we are trying to scale the current infrastructure and it's just taking them too long. We do see a number of technologies using to stream and batch data from applications. There's a number of tools that can do this in one. There's a number of ETL vendors that can provide this service. There's also some open source tools out there, but ultimately this is something that we work seamlessly with and have a number of customers that do both, again, stream processing and batch processing in the same data integration process. And the last example is the sort of next generation, if you will, applications that are enriched with machine learning logic. So in this case, this is an example of an application that we support today. It's using image recognition as the machine learning logic. So the data that's generated from the application is going from Kafka directly into MemSQL and being scored against an existing model. That scoring can happen in SQL. So we do have the ability to, through our extensibility capabilities, run machine learning algorithms directly on the data that's landed in MemSQL. If you need to modify or update that model, you can do that using an offline process, maybe it's TensorFlow or some other machine learning framework to continue to enrich and tune and improve that model. And then once that model has been defined, you can inject that into MemSQL and it can continue to score the data as it lands. So in this architecture, which we wrote up in a blog post around image recognition at the speed of memory bandwidth, this is our use of what is an ML function called dot product, and it allows you to do similarity matching between two vectors. So if you've got an image that you turn into a vector, that vector can be stored in MemSQL, and we can match or look for a closest match of that vector to a number of other reference images. And the beauty of this architecture is it's very efficient, it's clean, there's not a lot of moving parts to it, and you get great performance. And so again, if you want to look and learn more about that scenario, we have a great blog post that goes into the details. So the other thing that I wanted to highlight was real customer examples that are taking advantage of not just a real-time data warehouse, but how they're augmenting and supplementing their existing infrastructure to deliver better performance. The first will be Uber. Uber uses real-time data with high concurrency, which means a number of, I think they have hundreds of concurrent users accessing this system to track cars and drivers and riders, ultimately to optimize their fleet operations. So this is an operational system that's delivering analytics throughout the course of the day, and they want fresh, live, accurate data. So this is actually an architecture taken from a presentation that was delivered at Strata earlier this year. So this is, I didn't touch this up in any way. This is literally how the Uber team has described their architecture. Of course, data is landing directly into Hadoop using Kafka, so that's something in architecture that I already mentioned. They are using other technologies to enrich and organize the data within that system. But they also simultaneously push that data into MemSQL. And what MemSQL is serving is essentially an access layer for the number of users that want to run ad hoc reports, dashboards, a number of different types of queries throughout the course of the day. In this example, Uber is, I think, ingesting roughly about 30 days worth of data. You can imagine they have a very high volume amount of data coming in on a daily, hourly basis. So about 30 days of data stored in MemSQL, delivering immediate access in a number of different dimensions to their hundreds of business users that are running various offices throughout the world. They do take advantage of MySQL in front of MemSQL for some of the report caching, and so it delivers to them a little bit more performance. And what this showcases is just adding a speed layer on top of Hadoop to deliver interactive analysis to a number of users. So just some of the highlights of this architecture and what they're able to achieve. They can get real-time indicators to respond to the changing dimensions of their business. So if they see some hotspots in terms of capacity or the capacity changes in their business, and or whether it's changes in terms of the availability of drivers in certain areas, they're able to respond to those conditions in real time. They do take advantage of geospatial. Geospatial is a very important function for Uber because they are indeed taking advantage of location of cars and events, and they want that tracked in terms of location on a map. And then in terms of data sets, we're talking about analysis of millions of rows, and they're getting sub-second response rates. And they're also taking advantage of looking at historical and live data together. So, and lastly, they wanted to deliver large concurrency. So they had hundreds of users accessing the system, and they didn't want to see degradation in the experience to their end users. Kellogg is also another customer that took advantage of MemSQL to accelerate their analytics. They wanted to be able to perform profitability analysis of their customer logistics. They were doing that process on a weekly basis and wanted to get to performing that action on a daily basis. And that to them saved them lots of money, and they were much more optimized and efficient in managing that part of their process. And also they wanted to freshen the data from days to minutes. So they wanted to be able to get live data or up-to-date data without waiting for batch processes. So ultimately what they gained from this environment was the ability to do profitability analysis of their customer logistics data every day. So this was something that was taking them many, many hours to perform, and so it really was sort of a once-a-day sort of event, and now this was moved to minutes, giving them fresh data and also additional actions that they could deliver throughout the course of the day. So intraday analytics is very near and dear to the real-time data warehouse architecture, and that's what Kellogg's was able to deliver with this new architecture. So they also took advantage of eliminating some batch processes. So again, I mentioned ETL as a traditional batch process. Because of MemSQL and our enrichment layer with our transaction processing and pipeline capability, we were able to eliminate that ETL process from 22 hours to minutes. And also they got rid of the investment in their MySQL environment, and that increased query response time from what it was to about 80x improvement. So these are just a couple examples of customers that are taking advantage of a real-time data warehouse, accelerating existing investments, whether it's Hadoop-based or legacy or traditional-based, in some cases eliminating ETL and data integration processes, ultimately to deliver faster performance in real time. So that sort of concludes the presentation materials for today. So I guess we can transition into some questions. So let's see if Christy's got a few already queued up here. So I'll hand it off to her.
Thanks, James and Mike. James, we'll give you the first question. What are you seeing around cloud data warehouse adoption? Any particular use cases or market segments?
That's a good question. So cloud, I didn't necessarily have a slide in my deck, but I'll just give you a quick stat off the top of my head, because I think we also published it on social media, is that we anticipate, at least within the next couple of years, that like 60% of all sort of workloads will occur somewhere in the cloud, right? And that's a pretty big dramatic pick. But in terms of data warehousing, yeah, I mean, again, it gets back to, I think, my comment before on, where might your data land? If it's sort of landing directly in the cloud, it probably makes sense that you may want to process it there with some sort of a data warehousing tool, or if it's landing other places. But that is still growing. On-premise, I think, is still sort of the predominant right now from a trend standpoint, but that area is meant to grow and will grow. So.
Great, thank you. Mike, next question over to you. Can you share how MemSQL and Redshift complement each other for analytical workloads?
Yeah, absolutely. We see a fair amount of Redshift customers that are doing, very classic historical analysis of data throughout, whether it's for driving a business dashboard or reports. Where we see Redshift sort of having some challenges is around concurrency. So if you have a number of simultaneous users that need to access reports and data, even up into the dozens, there tends to be some challenges in delivering that at scale. And so you can use MemSQL to help offload or offset some of that concurrency issues and deliver great performance and still maintain that investment in that historical data within Redshift. Also, the other area of Redshift that we've seen some challenges is around the ingestion capabilities of the product. It is reasonably good at getting data, changing data throughout the day, but if that ingestion rate increases, there are thresholds that the platform just simply can't maintain. And then we also see a fairly limited amount of transaction processing that comes with that. And so if you're seeing weaknesses around concurrency, performance, and or the ingestion sophistication is rising, those are two areas where we complement and work with Redshift to address those challenges, but yet also allow you to maintain using some sort of Lambda style architecture to maintain two sort of warehouse environments simultaneously.
And Mike, I'm going to have you expand a little bit on that. So we've got, it's commonly known that most data warehouses can do transactions. What makes MemSQL different for this?
Yeah, it's true. Many data warehouses are able to process transactions. The real difference with MemSQL is that we can do the high, ACID level transactions without locking the system. So as your data is coming into the environment and you need to update or enrich that data, we can do that very freely without creating any blocks or locks on the data. So you get the performance of basically a stream-based systems with the capability of a traditional OLTP-based transaction processing environment. And we see a lot of customers needing that level of transactionality when it comes to a lot of changing data and you need to dedupe the data or do enrichment to the data, and you need to do that in real time. A lot of the traditional data warehouses have challenges in addressing that with the limited transaction processing that they offer, because it tends to lock the system, and or they can't guarantee that every transaction was committed to disk. So that's typically the high-level view there.
Great, thanks. James, a question for you. Are you seeing Hadoop displacing any data warehouse deployments?
Some actually, I do see that, but more than anything, I see, and a lot of that depends on what, say, the specific use cases or the organizational needs that do that. But what normally happens is that because data warehousing systems have been, around, since like the late 80s, and that concept has been sort of available, most likely organizations have perhaps a legacy system in there. And then if they want to adopt sort of a Hadoop-based system, and even the nature of Hadoop is somewhat changing, because there's a lot of different open source projects that are sort of associated with that. But they often then combine those two. And I think, Mike, I think you had one of your slides here that sort of showed, use one for perhaps landing it and then maybe doing some processing, and then it might be moved then to sort of a data warehousing system for another type of analytics. So that's actually a pretty common scenario, and there's sort of various use cases and means in which people could land it, because Hadoop's it's very good in a price per terabyte scenario, and so sometimes it makes sense to sort of land it there first. So
great, thank you. And last question for Mike. Could you give a few examples of where streaming data is being used for analytics?
Yeah, absolutely. That we, there's a number of, I guess, industries that have been around streaming-based analytics for a while. Financial services, of course, with trading systems and making sure fraud is not, in place within those transactions. But more interestingly, we see a lot more organizations that are like the Kellogg example or Dell, where they have very traditional architectures with batch-based processes. So they architected their entire system around a nightly based load process. And ultimately, they wanted to unlock that data to be available as on demand, meaning as the data changed, they wanted to reflect those changes in their data warehouse so that they could perform a report or do analysis immediately. And so in the example of Dell, they had a customer 360 application, and that application was being fed by their CRM system, but also telemetry data from their storage systems. And so what they want to do is be able to deliver insights as to what's going on with those storage systems at any given time, so that if a sales representative or a customer service representative needed to interact with a customer, they knew up to the second, up to the minute, what was going on within that customer's environment. Is their operations healthy? Are they able to deliver, perform to expectations? And so they were much more informed about the health of their customer in real time versus the prior process, which was they were sort of in the dark. They were getting updates maybe once a week or maybe once a day. And in many cases, that resulted in potentially uncomfortable conversations if some unforeseen issue had taken place with a customer and they weren't aware of it. So there's a number of, I think what we're seeing is a transition from not just the high-end streaming fast volume data sets, but organizations that have batch processes all throughout the organization, and they simply want to move to more on-demand based, real-time based systems. So there's a couple.
Great, thanks, Mike. And thanks, James, and thank you everybody for joining today, and have a great rest of your day. Bye-bye.
Thank you very much.